Welcome back, folks. This is Joe Samo. In this equation, you need to compare column A and column B. And the question basically is, which column is greater, or are they equal, or is it undeterminable based on the data given? Give this one a shot on your own by hitting the pause button, and then we'll do it together. I hope you tried it on your own. Now we're going to try it together. Let's draw the triangle out with the same kind of dimensions, maybe not drawn to scale. The big deal here is to look first at line BD. That is the height of the triangle, and it cuts the triangle into two right triangles. And then that line, the BD, that is one of the legs of a right triangle. Let's look at the one on the left. And here, the side AB, that is the hypotenuse of the right triangle. And basically, it's the hypotenuse because it is the side that opposes the right angle. And the hypotenuse is always the longest side of a right triangle. So back to this triangle, AB is the longest side, and it has to be longer than BD. BD is one of the sides of the right triangle, but it's not the hypotenuse, which, like I said, that is AB. Now, if you look at that quantity, BD divided by AB, AB is bigger than BD. So the denominator, which is the number on the bottom portion of a fraction, the denominator here is bigger than the numerator. Anytime the denominator is bigger than the numerator, then the number has to be lower than 1. Now let's go to the triangle on the right, and we have BC divided by DC. If you look at this right triangle on the right, the side that opposes the 90 degrees, that is BC. So BC is the hypotenuse of that triangle on the right, which means that BC is the longest side. DC, there on the bottom, that is one of the legs of the right triangle, but it is not the hypotenuse. So like I said, BC is the longest side in that triangle. So that number, which would be BC divided by DC, we have here the numerator is the hypotenuse, and the numerator has to be bigger than the denominator. Then the number has to be greater than 1. So column B, the number there would be bigger than 1. So now let's compare column A and column B. Basically, we determined that column A has to be some number that's lower than 1, and column B has to be some number that's greater than 1. So therefore, column B is greater than column A. All right, good stuff on that one. We're going to try another one now. This one, if points A and B are randomly placed on a circumference of a circle with radius 2, what is the probability that the length of chord AB is greater than 2? Try this one on your own. It's a great practice question. Hit the pause button and then we'll do it together. All right, so let's try this one together. Let's draw the circle the best we can. The radius is 2, and then let's see, we can draw point A anywhere on the circle. It doesn't matter because it's just the relationship between A and B. And basically what we want to do is we want to draw a chord of distance 2 going in both directions. And then if point B is within those points, then the chord AB will be smaller than 2, and then if point B is outside of those points, then it would the chord AB would be greater than 2. So anyway, so those two chords there is 2 and 2 going in opposite directions of A, and then we want to draw the radius, and the radius is 2. So we have here the two chords that are 2 and the radius that are 2. Now, let's see. Since the radius goes to the center of the circle to the circumference, then we could also draw a point from that center to the end of the chord, okay? And that, basically, we're going from the center of the circle to the circumference, so that would be another radius, and we know that the radius is 2. So now we have here 2 different triangles, and every side of both triangles is 2. So we have now created 2 equilateral triangles, where all equilateral triangle means all the sides are the same length. And I'm sorry here, it's kind of a bad drawing. But the gist is those 2 triangles all have sides that are 2. Now, a couple properties of an equilateral triangle, all the sides are the same and all the angles are equal. And all the angles have to add up to 180 degrees. And if that's the case and they're all equal, then each angle has to be 60 degrees. Let's focus on the center of the circle. You see here, then those 2 angles have to be 60 degrees. That goes out from the center. And then if that's the case, then each of those angles that are 60 degrees, they would have a supplemental angle that is 120 degrees. And we figure that out because, you know, if we draw that straight line, the angles in each straight line has to be 180 degrees. So if there's an angle that's 60 degrees, then the supplemental angle has to be 120 degrees. So now we have the 2 angles that open up to the chords. Those angles are 60 degrees, and then the 2 other angles are 120 degrees. So let's see. So the 2 angles there that are 60 and 60 degrees, that's going to be 120 degrees. And then the 2 other angles are going to be 240 degrees. And then the 240 degrees will open up to a point on the circumference that will produce a chord that's longer than 2. So the call of the question says, what are the odds, you know, if everything is placed randomly, that the chord will be greater than 2? Well, we have 240 degrees out of 360 degrees will produce chords that are longer than 2. So if we simplify that, 240 divided by 360 is 2/3. That one is a tough one, okay, but it's great practice, and I'm gonna keep producing these, so I encourage you to subscribe if you wanna see more of these in the future. Thanks a lot, keep up the practice.